Hello everyone, this lecture video is all about the effects of heat on the body, and let us start with defining the heat and temperature since you will be encountering those words here in this lecture. So first we have here the definition of heat. It is a form of energy which flows from a hotter region to a cooler region. And then we also have here for temperature, degree of hotness and coldness of a body. And then for the unit of measurement, Joule is the unit of measurement for heat, and Kelvin, Celsius, Fahrenheit, and Rankine are for temperature. Then we also have here the property, flows from a hot area to a cold area. And then the temperature, since this is a measurement, and you commonly uses a thermometer to measure the degree of hotness and coldness. The measurement increases when heated, the thermometer, and then it decreases when cooled. So those are the definitions. Let's proceed. So this is the normal body temperature in normal range up to 40 degrees Celsius. That is the maximum tolerance of our body. And then we have here the oral measurement, which can either be in Fahrenheit or in Celsius. And for rectal, where your rectum is located. So these are the indicators for that. For hard exercise, that will range up to 37 to 40 degrees Celsius when measured from the rectal or from the rectum. And then in terms of emotion here, this is the range, so on. Same with oral. If you are being measured from the mouth when you are performing an exercise, you will be between 36 to 37 because it is cooler compared to the rectum part. So if the body temperature here becomes too high or too low, there will be significant irreversible damage. This one, and even death. So when we talk about irreversible damage caused by temperature, this can be a mutation on the DNA or on the gene. So a mutation in the DNA is an irreversible one. You cannot alter that. You cannot cure that. Cell metabolism increases as body temperature increases as well. If there is an increased cell metabolism, it speeds up the metabolism because of the increased body temp, and it also increases the production of body temperature or the body heat. And if the body rise above, this is 42 degrees Celsius, if the body rise above 42 degrees Celsius, the body cooling mechanisms cannot keep up, and you will need an external intervention. Okay, you will need an external intervention to cool the body down, such as rubbing an alcohol on the body to cool down the body. So, next, what are the body's mechanism to get rid of the excess heat? We can read that using conduction, convection, and radiation. So let us first define these three again. So conduction is energy transferred by direct contact, okay, such as a span. When you touch that, you can feel the heat, so that is conduction. And then convection, the energy is transferred by the mass motion of molecules. So this is the upward flow of the air or downward flow of the air. And then radiation, this is the energy is transferred by electromagnetic radiation. You can feel the heat even though you are not touching it. So another example here, we have here this one. You will touch the metal. For convection, the hot air from the flames causes the air balloon to rise up because hot airs tend to move upward and cooler airs tend to move downward. Next, we have here the radiation. So radiation, even though there is no fire, it can cook your food, and when you come in contact with it without touching it, you can feel that it is hot, so that is radiation. Transfer by means of electromagnetic radiation. Then we also have here another example. So if you touch it, that is conduction, and then the hot air will rise, that will be convection. And then radiation, you can the hotness of the flames even though you are not touching it. And then what else? So blood circulation is forced convection, okay, because if there is a increased heat, there will be an increased blood flow. So there will be an increased body temp, and therefore there will be an increased blood flow if there is a forced convection. So forced convection, because we have here the gases, the oxygen and carbon dioxide, that will increase the body temp as it moves, as it utilizes the energy, and that will create an increase in blood flow. Now let us proceed on sample problems. I have here some reference that we will be using in these problems. We have here the activities, the power rate of energy consumption in kilocalories per minute and then in watts, and then the oxygen consumption in liters per minute. So let us proceed here. We have here the efficiency in percent of the body and mechanical devices. We have here this one. So in human body, then for mechanical devices. This is in terms of percent. And then we also have here this first problem. On a day when air temperature is 34 degrees Celsius, a cyclist is maintaining a speed of 15 kilometers per hour. How many grams of water must this cyclist evaporate each minute to get rid of the body heat produced by his activity? So let me take note of some important words. We have here 34 degrees Celsius. This is the normal skin temperature. And then we also have here the speed, and then amount of water in grams that must be evaporated per minute. So let us solve this problem first by determining the useful energy. So we have here from the problem, the first thing that we need to do is to determine from the table, this table here, the power consumption of the cycling. So in watts, so in cycling that will be 400. So since the problem is cycling at 15 kilometers per hour, so from our table, we have here this one. Let us use a highlighter. Cycling at 13 to 18 kilometers per hour, you will have a 400 watts for that. 400 watts. So that will be 400 watts. And then we have to determine the efficiency of the cycling. So to determine that, we have here the cycling, and the efficiency is 20%. So 20% converting into decimal notation, that will be 0.20. So we have to determine first the useful power, okay, that will be utilized in the work. So to determine that, that will be efficiency times the input of the power, which is the 400 watts from the table. So here you will have 0.20, the efficiency, multiplied to the input of the power that can be utilized or that has been used by the cyclist, that is 400 watts. So we will determine what is the amount of the energy or the useful work amount. So determine that multiplying. So meaning to say the useful work amount is 80 watts. And then we have to determine next the waste energy. Okay, this is the thermal energy that will be dissipated into the environment. Okay, when we say dissipated, let me use another table first. So this is you as a person. Okay, this is you. Since our body is considered to be machine, so we are the system. And we also have here the surroundings, your area where you are. So when we say dissipated, the heat is being pushed outward to the environment when the environment is cooler than your body. But when the environment is hotter than your body, it will transfer heat from the surroundings to the system, which is your body. Okay, if this surroundings is hotter, it will transfer heat here on you. But if it is cooler, then your body will transfer heat on the surroundings. So the law of conservation of energy will come here, the concept of that. We will be utilizing that concept, meaning to say energy cannot be created nor destroyed. It just cycles from the surroundings to the system. And then let us proceed here on the next problem, since we are going to identify the waste energy. To determine the waste energy, which is the heat energy that will be in terms of power, that will be the input of energy that can be used in the activity, which is 400 watts rather, minus the useful amount of energy that can be used in the output, or the power of the output, which is 80 watts. This is the energy that your body will use, and this we have to subtract that to get the waste energy, which is the thermal energy. So subtracting that, you have the 320 watts. So this 320 watts here, this is the waste heat. This is the one that will dissipated into the surroundings. And the next, so you are being asked from the problem, you are being asked to determine the grams of water. So since we will be evaporating a heat, we have to determine that. To determine that, we will be using this formula. Okay. By definition, power is energy per unit of time. The Q is the energy, representing the energy, and then T is the time. So how did we arrive from this formula since we want to determine the energy? This is a triangular formula. Let me redraw that. So we have here the heat, the P, and then the Q, and then the T. So since we are looking for the Q, or the energy, this is multiplying the waste heat to the time. So multiplying that, you will have here this formula. So the waste heat is 320 watts from the previous solution here. And then the time is 60 seconds since you are being asked per minute. Okay, so from the problem here, you are being asked per minute. So, each minute is 1. So, from that problem, okay, so we are using the 60 seconds because the watt unit here, if you will expand that, that is joules per second. Okay, joules per second in general is watt unit. So, we can cancel out the second unit here already and we will have the energy for joule. Then, multiplying that 320 times 60, you will have 19,200 joule as your heat energy. Okay, and then next, we have to convert the joule into calories. 19,200 joule. We have here 1 calories is equivalent to 4.184 joules. So we have to arrange it in such a way that we will be able to eliminate the joule unit since we want to convert it into calories. So cancel the joule unit here and then multiply and divide. We'll have 4,588.9 or just 4,589 calories, and then we can convert the calories into grams already. So to convert that, we will be using this formula for heat of vaporization of water and mass in terms of energy. This is the formula for that. So we have to arrange that in such a way that we will be able to eliminate the unit. So since we want to convert that into grams, the calories, so we have to obtain the mass. Okay, so that is Q and then mHV. So therefore, the mass is Q over HV. The mass is of equivalent to energy over the heat of vaporization of the water. The next thing that we need to do, we have here the value of the 4,589 calories from here. And then we also have here this one is constant, the heat vaporization of water in body temperature, that is 580 calorie per gram. This is constant. So, already given. So, what we need to do is cancel the calories since we want the grams. Dividing this one, you will have 7.9 grams. So, therefore, where is the problem? Therefore, the cyclist will evaporate water per minute at about 7.9 grams. So, that is the answer for this problem. 7.9 grams. And then, let us have a second problem in relation to the first problem. How much will the temperature of the cyclist in the previous example increase in 1 hour if none of the body heat generated is lost to the surroundings? Assume the cyclist mass is 76 kg, which is normal, and the specific heat is 0.83 calories per gram times the degrees Celsius. So this one is constant, given already in the problem. And then we have here, take note of that, we will assume that none of the heat is lost to the surroundings, meaning to say none of that is lost. So we won't get the waste heat. Okay, we will just determine the amount of temperature. So to determine that, we have here this value, energy is equivalent to the specific heat multiplied to the mass multiplied to the change in temperature. Since you want to find the value or the change in temperature, you have to manipulate this formula. So to manipulate that, you have here, let me erase that first. Okay, you have to multiply both sides in this one, SM. Okay, again. Okay, multiplying both sides, SM, the specific and mass, SM. So you will be able to cancel this one, and then you will be left out with this formula. Okay, meaning to say that will be change in temperature is equivalent to the energy over the specific heat multiplied to the mass. So the energy is equivalent to 4,589 calories per minute, which is given on the first problem. And then the time is 60 minutes because you are being asked to find the change in temperature if there is an increase in 1 hour, and 1 hour is equivalent to 60 minutes. That is in minutes because the energy instead of hour, because the energy here is in per minute. So you have to make the signs alike. And then over, the specific heat is given 0.83 calories per gram multiplied to the degrees Celsius given on the problem. And then the mass is 76 kilogram. You have to convert that into grams by multiplying into 1,000 because the unit here is in grams. So, in order to eliminate the unit, you have to convert that, okay? So, that will be 76,000 grams. And then, let us cancel the units here. Calories, and then minutes, then grams. You will be left out with the temperature unit, which is degrees Celsius. Then, solving this one, multiplying this one, multiply that one, and then divide, you will have 4.36 or just 4.4 degrees Celsius. Mean to say, after 1 hour, the cyclist will experience an increase of 4.4 degrees Celsius. So, that is the answer for second problem. And that is all for this video in the effects of heat on the body under the topic heat and temperature in health sciences of physics.